Students, the students who are pursuing MSc Physics, I am going to make videos for them. The first of all, I am going to start with the quantum mechanics of MSc first year. The book which I am going to follow is from Indira Gandhi National Open University. So I will advise, if you have this book, please open this book along with this video so that it is convenient for you. So I will explain each chapter of this book, but my more focus will be on the numerical portion. So let us start. First chapter of this book is the wave particle duality. This chapter is very basic chapter, and it is just the revision of our 12th standard syllabus, that because we have already studied these topics in our previous classes. So let us start. First topic is de Broglie hypothesis. According to this hypothesis, the all the matter in this universe is can exist in both the forms, that is in the particle form as well as in the wave form. So as we know that the matter can have the wave nature, so wavelength of this wave is given by de Broglie, that is called de Broglie wavelength, and this is the formula of de Broglie wavelength. Lambda is equal to h by p, where h is Planck's constant, which is and its value is 6.6 into 10 raised to power minus 34 joule second, and p is the particle momentum. So this is the next formula, that is the energy of the particle. We know that energy of the particle is equal to h nu. So from here we can calculate the frequency of the particle. Nu is equal to E by h. So this is also an important formula. So this is all about it, de Broglie wavelength. This is the example in which we have given the cricket ball moving with the speed of 50 meter per second, and mass is also given 150 gram. So we just need to use this formula, lambda is equal to h by p, de Broglie wavelength, as we know that p is momentum, that is mass into velocity, and by just substituting these values we can calculate the de Broglie wavelength, and we just need to convert it into kilogram because it is given in grams. So this was an easy numerical. So in this chapter, which all the numericals are on the basis of de Broglie wavelength. So here are four formulas of de Broglie wavelength. First is lambda is equal to h by p. If we have given the momentum, we can use this formula, and we know that p is equal to mass into velocity. So another formula becomes h by m into v. Lambda is equal to h by m into v. And if we want to find the de Broglie wavelength in the form of kinetic energy, we can use this formula. We know that kinetic energy is equal to half mv square, and if we multiply this by m and divide by m, we know that m into v is p momentum, so it becomes p square by 2m. So this is the kinetic energy, and p square is equal to 2m into k. From here p is equal to 2m k square root. So now the formula of de Broglie wavelength becomes, as we know that de Broglie wavelength is h by p, so it becomes h by 2m k. So this is the third formula. So all these formulas we just need to remember for numericals. So in Davison and Germer experiment, we know that the kinetic energy of the electron emitted by this electron gun is equal to work done by potential that we have applied to this electron gun. So work done by potential, we know that potential is equal to work upon charge, and work done by potential is equal to Q into V. And for electron, we know that charge on the electron is E, that is 1.6 into 10 is for minus 19, minus for electron, coulomb. So for electron, work done by potential is E into V. So kinetic energy of this emitted electrons is equal to work done by potential. And from here, the last formula of de Broglie wavelength becomes lambda is equal to h by 2. We already have done that lambda is equal to h by 2 mk kinetic energy, and from here kinetic energy is charge into potential. So this is the another formula, 2m charge into potential. Charge q symbol is used for any other particle, and if we have given the electron, then we use E into V. So this is all about the de Broglie wavelength. So next topic is matter waves, important topic in which we study about the matter waves by using the wave equation. This is the important wave equation in which d square y by dt square is equal to 1 by v square d square y by dx square. And the solution is this solution of this de Broglie wavelength is a sine kx minus omega t, where k is the wave number, that is 2 pi by lambda, and omega is 2 pi nu. So by substituting these two values, our solution of the wave becomes a sine 2 pi by lambda into x minus 2 pi nu into t. So this is just a simple derivation in which we find that momentum of the particle becomes h cut into k, and energy of the particle is h cut into omega. And the phase velocity of the wave is equal to omega into k. So these all of these are important formulas. And the group velocity of the wave packet is equal to d omega by dk. So this is all about this chapter, and I hope you like this video. If you like this video, please share and subscribe this channel. Thank you so much.